In the final section, we will actually use the data from the Affable Bean database in our application. To do this, we'll make use of the JSP Standard Tag Library, or JSTL. Before we do that, we're going to make sure that there's an easy way to associate the product images with the products they represent. The tutorial developers have already done this by carefully naming the file names of the images that we will use. Their names match the text of the product names from the product table in the SQL database. So if the variable product holds a row from the product table, then in the expression language, $product.name resolves to the name of the product. So we can get the file name of the corresponding image by writing $product.name.png, as you see here. From the last section of the tutorial, we already know how to get the path of the folder that holds the product images. So as long as we have a reference to a product row, which we can get from an SQL query, it's easy to get the path and file name of the corresponding image. Our index.jsp file has an image for each of the 4 categories on the welcome page. To access these images, we need the names of the categories. We'll get them by first accessing the category table from our database, and we'll do that with the SQL query tag. In the query, we'll select everything from the category table using the SQL query select star from category, and we'll store the result in a variable named categories. When we click OK on the Insert DB Query wizard, we get the following. The SQL taglib directive is placed at the top of the page, and the SQL query tag is located from wherever we placed our cursor when we invoked the Insert DB Query wizard. We created this query so that we could get a reference to the result set, which we are storing in the categories variable. An SQL query returns a result set. An SQL result set is a set of rows from a database, as well as metadata about the query, such as the column names and the types and sizes of each column. When we use the SQL query tag in a JSP page, the result set returned by SQL is stored in a Java result object. Here's the API for the JSTL result interface. The method getColumnNames returns an array of column names. getRowCount returns the number of rows in the result set. getRows returns an array of maps. Each map is a mapping from column names to the values in a particular row. getRowsByIndex returns the rows of the result as a 2-dimensional array. So instead of accessing the values in each row by their corresponding column names, you can access them by their column index. More realistically, this method is used when you simply want to iterate over the rows and then iterate within each row. For example, you would use this when you're putting all the rows and all row data in an HTML table, like we did when we were testing the database connection a few sections back. Finally, isLimitedByMaxRows returns true if the query could not return all the rows that matched its form due to a maximum row setting. This slide shows how we iterate over a collection of objects using the forEach tag from the JSTL core tag library. The collection we iterate over comprises the rows from the result set. The result set is stored in the categories variable, and the Java expression language uses the dot notation to access properties from a Java object. Properties are derived from accessor methods. As long as a class has an accessor method called getRows, then it has a property called rows with a lowercase r. That is what the expression $categories.rows refers to in the first field of the wizard. From the last slide, we saw that getRows returns an array of maps. This array of maps is the collection that we want to iterate over. As the iteration proceeds, the current row from the array will be stored in the variable category. Let's see how this looks in code. When we click OK, this is what we end up with. The core taglib, denoted by the prefix C, is imported at the top of the page. The for each loop is currently on lines 26 and 27. You can read this for each loop as saying, for each category in the rows of the category table, do what? Well, for now, do nothing. Ultimately, though, we'd like to create a div box for each category that had a picture of the category and linked to the category page of that particular category. Now, there's only one category page in our project, but we can pass a parameter to that page, telling it what the selected category should be. So here's what we're going to place in our iteration. For each category row, we're going to create a category box div that does the following. First, it should link to the category page and pass the category identifier, which is a number from 1 to 4, as a parameter of the page request. Second, we're going to label the div box with the category name. And finally, we're going to display the image for the category. The images reside in the img/category folder and are named using the exact category name that we're using in our database. Once we've done this, we can delete the code that was serving as a placeholder for the category boxes. Now when you run the application, this is what you should see for the welcome page. Try clicking on the dairy image. When you do, your browser sends a GET request to the server for the category page, but it also sends the identifier for dairy as the query string. So you will get to the category page, and the URL you see in your address bar will be appended with a question mark followed by the number 1. Right now, the category page ignores the query string, but let's recode it so that it incorporates the selected category and the pictures of the products. The code you see here is the code we're going to add to the categories page to make the left column, the category navigation, work correctly. The first 2 lines reference the taglib directives for the core libraries and the SQL libraries. Lines 5 through 7 query the database for all the fields and rows from the category table, and it stores the results in the variable categories. Then we're going to iterate through the category rows like we did on the welcome page. During each iteration, we're going to do one of 2 things, depending on whether the current category is the selected category. To do this, we use the choose tag from the core library. Inside the choose tag, you can set up multiple when tags that check if a certain condition holds. If the condition does hold, the code inside of that when tag is rendered, and any other when tags are ignored. If no when tags condition is true, the code in the otherwise tag is rendered. In other words, only one of the blocks inside a choose tag is ever rendered. In this case, there are only two choices, a when block and an otherwise block. The when block is executed when the category IT is equal to the query string from the request. That's going to be our selected category. In all other cases, the otherwise block is executed. Now if you go back to the home page and choose the bakery category, this is what the category page will look like. The left column now correctly displays that the bakery category is the selected category, and the others are not. Okay, now we still have to finish the table on the category page. To do this, we first set up another SQL query. In this one, we're getting all the rows from the product table for the chosen category. Notice the question mark in line 10. The question mark refers to the SQL param object in line 11. In other words, it refers to the query string. Also, note that even though category ID is an integer and the query string is a string, we can compare them because the query string will be coerced into an integer. Once we get the products from our selected category, we'll store them in the variable category products. Now we can create our product table using a for each iteration. Note that in line 40 there's a var status attribute in the for each tag. This is a counter that starts at 0 and increments with each iteration. We're going to use it in the next line to decide what color our rows should be. For each product in the rows of our result set, we're going to choose a CSS class for the row based on whether the counter is odd or even. If the counter is odd, our row is going to be white. If the counter is even, our row is going to be light blue. We are able to do this by using the question mark colon operator from the expression language. This operator does the same thing the one in Java does. If the condition evaluates to true, the text before the colon is returned. If the condition evaluates to false, the text after the colon is returned. Once we have our row color, we go through the columns of our row. In the first column, we're placing our image. In the second column, we're placing our product name. In the third column, we're placing our product description. In the fourth column, we're placing the product price per unit in euros. And in the last column, we have our Add to Cart button. The Add to Cart button is part of a form in which the first input value is hidden. This is the value we want to send to the cart if the button is clicked, the product identifier. Notice that the method on the form is specified as post, so this form will send a post request to the server. Once we have modified the code, our category page will look like this when bakery with ID equals 3 is the selected category. Finally, we want to place the category name above the table. The SQL query you see here is different from the one we used to help create the previous table. This query is asking for all rows from the category table in which the ID equals the query string. In fact, there must be only one such row since the identifier is the primary key and therefore unique. Furthermore, the query is asking only for the name field, so only one column. Therefore, the result set will only have one row and one column. Basically, we're asking for the name corresponding to the category identifier. But since the query returns a result set, we have to break it apart before we can access our category name. We do this by using the expression $selectedCategory.rows indexed by 0.name. SelectedCategories.rows gives us access to the array containing a single row mapping. We use the index O to access the first and only cell of that array. And what is left is a mapping from the field name name to the value, the actual name of the category. In the expression language, we access map values by using the dot notation followed by the key. And that's it for this chapter of the NetBeans e-commerce tutorial on connecting your application to the database. We're at about a halfway point in this tutorial, so this might be a good place to pause and review what you've learned so far.